Welcome back everybody to the Annex K3 printer. I have made a lot of updates to this guy since the last time I made a video, and I wanted just to go through it and show you guys all the fun updates I have made. Thank you guys so much for watching my last video. It actually got more views than I expected it to. But yeah, without further ado, let's hop right into this. All right, starting off with the motors, we have some 2804 motors, and since last time, I don't think too much has changed. But as you can see, I've added some thermal paste to the actual motors because these guys are going to be running pretty hot. I want them to be at roughly 2.5 amps, which is going to lead to a couple other differences when it comes to electronics. But on top of that, we've got some really cool water blocks made by Vez 3D for the VZBot. And getting a little bit more up close with the actual mounts, we've got them right here, and this thing is pretty sweet, you know. So these are aluminum mounts made by Vez 3D for his VZBot, and I decided to take them on for this K3 project, as you know, because this project is going to be water cooled, and that's a theme you'll see, is that there's going to be a lot of water cooled parts for this. But starting off with the motors, these are some compression fittings I found on AliExpress. They are compatible, and I am using the 2804 long boys. I think I mentioned that. And one thing I noticed was that these motors use Phillips head screws. I think that's used on purpose by LDO so that they don't get tampered with, and if you try to, they get stripped, and then you don't mess with your motors that much. But one of these guys was really annoying to remove, and I found that these screws provided by the Vez 3D kit were just a hair too long, like 0.3 millimeters too long. So I shimmed all of my motor mounts, and I got them all within the spec that they needed for this. So yeah, all of these are now fitting, and they all look really cool, really sleek. And yeah, that's about it. As for thermal paste, I decided to use some PC thermal paste. I think it's from Arctic Night, something like that. But I saw from Vez's video that these motors shouldn't get too much hotter than 60, 70 C, which is well within PC temperatures. So yeah, I'm gonna put those on. If I don't like them, I can just change them, so it's not too big of a deal for me. And yeah, those went on really well. Moving on to the next bit, we've got these cool titanium rails. So this is similar to the thing that's used in the Voron 2.4. These guys right here, and right here, it's actually on all four corners of the printer, since it's a four-corner printer. And so what this will do is that as the printer heats up, it's a dissimilar metal which will expand at a different rate. So the aluminum will expand much quicker than the titanium, and that plate will just keep the whole frame really rigid, really stiff. I really like it. And it actually has, if you can see, let me see if I can focus in, it's got the actual Annex logo on there, as you can tell right there, etched into it. So I think that's a really nice touch to this whole build. Up next, we have got the tool head, which is the actual thing that started off this entire project. And here it is, pretty much fully assembled. But before we get into it, I really want to show you guys what it took to get over here. There were a couple revisions, and let me show you that older clip right now. Here are the actual pieces made by the one and only PCB Way. I'm try to show you guys the box. Boom, PCB Way. So here it is. I wanted to see which manufacturing method I liked the most, especially before releasing these files out to the public. And I decided to do two versions, one that was 3D printed in aluminum, and I really like this. It looks cool. I mean, one, it looks cool. You don't have to assemble any parts, so it really saves on fasteners and screws. I don't know if it's any lighter because all of these posts are solid, but it is pretty cool, and it looks cool, and it works equally as well. One thing that I was not a big fan of was the flatness on this area and the flatness on this area. Depending on the way they orient this model, how it's printed can really mess with the flatness. And so there's that. I think you might have seen on the printer was like an older version of this actual tool head. I found out the hard way that I had somehow made the posts just a hair too short, and that led to annoying issues. And I want to put up a little photo of that. That was just a complete oversight, something I would have never done, but it gave me the opportunity to prototype on a new design. And one thing that this design doesn't have is a little cutout here, because as you raise the posts, you need a little cutout so it doesn't hit the rails. Thankfully, with the CNC stuff, that was not in the queue just yet, so I was able to ask PCBWay to modify a file, and they are super cool about it. And I got these parts black anodized, which you can't do with the 3D printed stuff. This is just a CNC'd version of it, and this thing looks top notch. I got all the holes drilled out for their respective taps. So yeah, next thing we can do is just attach it, put it together, and actually get it on the tool head and show that. One other thing I wanted to show was I got this 3D printed, well, I guess everything's 3D printed, but this MJF printed fan duct. I actually got this from another supplier, but you can get this from PCBWay as well. One thing that was another clear oversight on my end was a little interference right here. I kind of rushed out to get this part made, this CNC part, because I needed everything kind of like sooner than I was expecting, but really before all the tariff stuff hit. So I was really trying to rush out, make these parts, you know, kind of get out the door. And I made a small little error. So I notched out just this corner piece with a hand filer, and it came out really nice. And what it allows it to do is when the tool head sits on it just like this, you know, I don't know if you can see that just clearly, but there is a notch that is needed. Wow, you can't see that at all. But that notch is needed right there. Right there. Boom. Right. And it's not an alignment feature. It's just so that it clears this actual piece right here. So that was a really, really easy little fix, and it all works. So I really want to get this put on the tool head and get that fully attached and make sure this is all going good. And then we're done with the tool head section of the Annex printer. I am gonna go with the CNC version. I don't know if I explained it, but the real reason was just because you can't get the flatness that you need with 3D printing that you could with a CNC, and that's what made me get the CNC version, hence why I made two versions with a couple more hardware and that little cutout right there so that it actually can fit under the rails and everything. Also, if you guys are wondering how precise this whole thing is, look at how amazing the machining was. It doesn't even touch or rub. It's perfect. There's like a small air gap right there, which is just enough, which is great because that means that when you install it, it's not flexing and bending the rails. But like, look at that. It just kisses the bottom rail. Boom. Gotta love it. So yeah, this little tool head right here is actually what sparked the entire project for this printer. I really wanted to have a fast, high output printer with a really good tool head, and the only tool head I knew that would be great would be the Goliath. So I started modifying the tool head just to fit the Goliath, and while I was there, I knew that the motors were going to get hot, might as well water cool it. And this led me down the very cool rabbit hole of completely customizing this, completely customizing this tool head right here. And yeah, it's pretty much a custom bracket that fits onto these two linear rails right here. And then afterwards, I put a VZ Extruder Low extruder right here. And then of course, water cooled the plates, or the water cooled version, and nothing on the back. It has no CAN connection. It will be connected directly to the board. So one thing I really did make is this nice PCCF strain relief that you can see right here. And I haven't tested it out just yet, so I'm not sure if it will be good, but looking at past designs and where it should be mounted, it should be totally good. And I think I've already spoke about the CPAP cooler because, you know, as you're moving, you're going to need some really cool cooling. And that's about it, really. And I've got also this LED, which is like this, yeah, just this normal LED that I've got mounted onto the actual tool head. It's going to be pretty cool. Got it all wired up, and all of that will be sent straight to the electronics bay, which will be super coming up very soon. So yeah, there is that. Moving on to the bed, the keen-eyed viewers will have noticed that my bed is not silver. It is not made of aluminum. I actually got the graphite bed custom made by N20 Factory. I just sent them the drawing that's on the GitHub, and we've got the bed mounted up right here. I'll show you guys a photo of the underside of the bed and how I've got it wired. It's pretty nice and simple. I just used some Wago clips right here to get it all mounted up, and it has been a dream, at least for now. And then I've got these thermal fuse that's going to be connected to this Wago connection here. So I've got all of that done and mounted up. Got very lucky that these are M5. I did not see that on the drawing, and that was my personal bad. But I also found these nice little wiring clip tie downs, which help me tie down everything and make sure everything's really tidy. Also, we have some adjustable screw points right here to help get the height of the bed correct. So these are really good. I didn't have to change the screws, but I think I used M3 by 35s because I found that way easier to mount. I think the bed is a little thicker than what the manual might have, or what the drawing might have called for, but it's amazing. It looks really cool. And as you can see, we've got some more metal components. Shout out to Mathematical Potato, because he designed all of these metal 3D printed aluminum Z components right here. These were super fun to get made and to install. And so yeah, I got all of these printed out, and these are all 3D metal 3D printed, like I mentioned. Got them tapped. I had to buy a little bench vise, which I highly recommend. Yeah, so I highly recommend getting a bench vise for all of these. These guys are really cool and really sweet. And I want to see if I can show you guys the other one. So right over there is the third guy. And yeah, it's been amazing. So those guys are really fun. So yeah, I tried to be kind of fancy. As you can see, there is one printed part right there. And that is the printed part. I printed these out in PCCF as well on my Voron, but there, you know, I was thinking, since, you know, all of this is 3D metal printed, why don't I metal 3D print the actual, what they call more grip retainers, and then just tap the ends so that they all fit and work. Well, I did not account for the parts growing as they are metal 3D printed. So those parts did not fit as much as I wanted them to. So I just reverted back to PCCF. It's been amazing. I've just left this on there for, I don't know, a couple weeks, and it's been able to hold the tension. I tensioned all of these, as you can hear, to the correct amount, and they are all looking good. I'm not sure if I've mentioned this in this video, but I think I mentioned it in the other video. We got some ceramic bearings everywhere, and here they are, even for the actual Maxwell mounts for the metal 3D printed bed. So we've got those installed. They look really cool. They smooth. They work really smooth, so that's amazing. Also, as for tapping the parts, I forgot to mention this as well. Be sure to get one of those little mini bench vices. I'll try to link one in the description. And be sure to get some brand new taps. These parts are printed, or they're designed so that the internal diameters are printed a little bit smaller than what is required to tap. So do not try to tap the parts directly out of the box. Drill them out with a 2.5mm drill bit, and then tap them with an M3 tap, which is really easy. Of course, use some IPA or Tap Magic lubricant as some tapping lube, because you will definitely need it. And yeah, if you have a drill press, that would be really good, because that guy can help you get straight taps. And if you have a vise, even better. So that is that for those parts. So one of the things I mentioned in my last video was something about end stops, and I designed my own end stops right here, and I will make sure to show you the real versions that I've got attached right over here. But I decided to make my own end stops because sensorless homing with 5160s is just, in my opinion and in my experience, just horrendous. So I decided to make my own, and all I did for these guys is I extended out my slots right here, because for whatever reason, when I printed it out, it would not work. And then of course I modified the body so that an actual end stop can work. So if you're curious, the actual end stop that works for this is called the D2F5. So that is the one that I use, and one without the clicker. I mean, you can use the one with the clicking bar, but one without the clicker. And then I'm just going to solder these on. And one thing that I didn't realize when I was making it, but I, of course, designed this part to be SLS made. I always wanted these parts to be SLS made. I think since it's in the front of the printer, I really didn't want it to look 3D printed. I wanted it to kind of mimic a metal sort of look. And so I got them SLS made, which of course means that they're not the best 3D printed files on an FDM printer, but they do work. And I've got them for both the X right here and the Y right here. I've also got the opposite sides SLS printed, just because I wanted these guys to look pretty cool and to do their thing. So yeah, that's one little project. I've still got them I still need to get them soldered together, but to get the correct lengths, you need the backpack on, and we'll talk about that in just a little bit as well. But also we will be using M2 self-threading nuts right here. I know some people really hate M2 self-threading nuts. I love them. I'm a big proponent of them. So yeah, there is that. There's probably going to be a version with some other fastening screws if people decide to remix it. But for now, that's going to be the way. One of the last things I wanted to talk about on this printer would be this metal bottom plate that I've got. So I really wanted some way of covering the wires, along with making sure that the cables and stuff weren't really seen. Also, I'm a very messy printer. If you guys are like me, I tend to just like swipe stuff as prints are finished, and it can kind of lead to some gross stuff here. And there's a pretty complicated mechanical system for the Z motors, and I didn't want anything to get bound up and grossed up. So I talked to some people on the Discord, and I found this DXF for this plastic plate, or for this plate right here. A lot of people got it made in the same sort of acrylic or polycarbonate as the front door. And I decided I wanted mine to be metal because we've got like a full metal jacket theme going on here. So I got this thing metal, and then I realized that this huge metal sheet did not really match the black aesthetic that I was kind of going for. So I took some carbon fiber wrap that was super duper cheap, and I just wrapped this whole thing. So if you guys can tell, there's a sweet uber carbon fiber finish to everything, just that level of bling that you want to have to make it a little bit more personalized. But yeah, this was super cool. I got this off of SendCut Send. I think it was like $40 shipped to my house, and then the roll of vinyl was maybe $5 or $6. And I just took an X-Acto knife, put it on a piece of glass, and started tracing it around. On the bottom right there, I did need some spacers, so I created some, I think 9.5 millimeter spacers, and I printed these out of ASA. And then we've got spacers here because I think without the spacers, the part of the tray will hit this little piece of the belt, and I don't want this to ever break or be a catastrophic end. So definitely got that made, and added spacers and all of the fittings all the way around. I have also found these parts right over here. They're like sealing parts that I found. I think I found it on the GitHub for the Annex K3 mods. I highly recommend you guys look at that while you're looking for parts on your Annex K3. You can find some really cool mods like the few that I have in mine. That's going to be super duper cool. But I put them on all four sides. This should help with sealing and a little bit of better temperatures for high temp stuff. But after that, we have pretty much only one piece left to show you, and that's going to be the actual top hat that we're going to show you. Let me get that and show y'all right now. So speaking about mods, this is one of the coolest mods I think I found on that GitHub repository, and I will make sure to link that. But it is a one-piece Annex specific K3 top hat for this guy. And so usually the top hat is made into several sections, about 3 sections per side, and then you print them together, and you either glue them or you can mechanically bind them with bolts. But if you're lucky, and I will show some clips about this printing on my Voron, I've got a 350 millimeter Voron, and it printed this all down in one piece. This was a very difficult print. I failed the first time, and then the second time I had to let it print a little bit. Of course, add some vision miner, first layer stuff, dry out your filament, all the necessary things. But even then, I had to let the first layers print, wait like an hour and a half until my nozzle cleared, and then I put some huge binder clips all the way around my bed, and it printed phenomenally. If you guys can see, these layers are perfect, and that is not a print defect, that is just where the print ended. So it went around in a circle and it did that. Of course, nobody can see that. That is a feature, not a bug. So that was really cool. And then I installed some heat inserts for the top. So that was a very cool thing that I wanted to show you guys. So that is the last bit on the printer. So yeah, I think that was a really, really cool thing. I'm very, very proud, as you can see. And the whole piece is actually flat. I wish I had a bigger table to show you guys, but this thing is dead flat. It doesn't warp. There are no wobbles. It's my proudest of prints because of how horrible it is to print on such a large printer. You've got all this volume right here, so it all wants to taco up like my fingers right there. But yeah, let's get on to the next section. Awesome. So moving on to the next part, this is the radiator stack that I created. And this is an uber overkill thing that I just had a ton of fun with designing. And I'll make sure to show the actual CAD of how this all works. But essentially, it's a three-part piece. We've got the back piece that interfaces with the back of the printer. We've got a mount right here that interfaces with the radiator. Of course, this is a cheap aluminum radiator. Something to know about this entire project is that every part is made out of aluminum. You can't just use copper lines in an aluminum. So all of the PC stuff that you will find readily available, you sadly can't use on this, otherwise you heavily risk galvanic corrosion. So it took me forever to find a radiator for this project, and thankfully I found one, but that was really annoying. That also includes all of your fittings and your tubings and everything. So if you do use some incompatible materials, make sure to use some anti-seize or anti-corrosive parts for the mating liquid, but you can't really do that if there's like a connector, right? Because the liquid's going through the connector. But that's just one thing to know. But on a side note, there's a adapter plate to mount the radiator to the actual mounting plate, and then we have a little slot right here, if you can see, that fits this one piece pump res combo. So I found this from doing all my research on like mini PC builds, and this is super popular in those and probably even bigger PC builds. But what it does is that it fits right there, just like that. And that is your whole assembly. Of course, the wiring and tubes, like you'll have this come out to this connector and another connector up there. But yeah, this is like this little side pack, or side pack, I guess, that's going to connect to the whole printer. And it's got some feet right here because, as you know, motors will make a little bit of noise, and especially this pump motor will have some vibrations. So I wanted to add some feet, and these are some feet I had laying around from my last printer project that should be up here so you guys can watch. But I had some feet left over, and I decided to use them for this, which actually allowed this whole thing to be self-leveling, which is cool. I found some black cheap fans on Amazon and some grills there. So yeah, I'm going to try to show some CAD how it all goes together, but essentially there are three big posts right here, here, and here that allows the two parts to mate together. And then I've got some fasteners here, here, and in this little hole that hold it all together. And then we've got the feet bolted in from both sides. And yeah, it pretty much all stays together like this. I printed this all out of CF-ASA because I wanted it to be super duper strong. And the keen eye among you have seen this, which is an inline radiator temperature thermometer. I also got this in aluminum. Be sure to make sure you get these, but I got this from Alphacool. And this is inline thermometer. This was like 25 or 30 bucks. It's incredibly expensive compared to the radiator. But I wanted to see the temperatures and have that displayed in Clipper. This is a fancy kind of thermistor, so I found some ways to get that to read in Clipper, and I'll show you guys in the next episode. But yeah, this is the radiator stack, and let me show you what it would look like on the printer, just like that. So yeah, this is what it would look like just like this on the back of the printer. And it's not too obtrusive. It's about, I don't know, 35 millimeters tall. And this will just sit on the back of the printer. So, you know, you'll have the side pack right here. This will be the front door. And on the very back right over there, I'm going to have this. I wanted this on the back because I have a very limited space on my desk so that you could put it somewhere where I could keep it away from the wall and still on my desk. I didn't want to make it too wide, but I think since it's going to be full of water, it would make sense to probably put this on the opposite side of the side pack, make sure the whole printer is balanced. But I don't think that's going to be a big issue for this. But this was something really cool that I had the chance to work on. So this was something super duper fun. Of course, for this entire project, I'll probably make a Printables link where you can go download everything and link that to all my videos once this is completed and I see that it all works, including the CNC files for the tool head. But that was the radiator mount. And for anybody that was curious on what the loop is going to be, we're going to have two separate loops. We're going to have the loop coming from the hot end into the reservoir, and then another loop that goes from all of the motors through the motor drivers back to the reservoir. And so we're going to have this little splitter that I found on AliExpress. I think this is mainly aluminum. That's the hardest thing to find, but I think this is mainly aluminum. It has a bit of a chrome plating, so I'm hoping that's not on the inside. But it's an aluminum part, and it's got a splitter right here. So if you can imagine, there's going to be two cables. They come in right here. It's going to go from the pump, or sorry, reservoir into the pump into the radiator. So it's going to connect from there to the top right here, and then there is going to be, it's going to go through the radiator, get cooled down, and then we're going to measure the temperature here, have this come all the way back up, and then it's going to get split again to the other parts. So then it goes back into the motor and back into the hot end, and then we should have pretty much a cool and awesome loop. The tubing I found is going to be some 4mm ID tubing, so very narrow, really cool tubing. And the only reason why I don't have the loop done is because these fittings don't fit, and I had to go get some custom fittings from McMaster-Carr that do fit, so those should be in and are material appropriate, so that'll be really cool. But that's pretty much all the water cooling and the actual parts of the build done. Move on to the electronics, and I can show you guys all the craziness that's happening there. All right, moving on from the actual physical build to the electronics, we've got a lot going on here, and yeah, let's slowly break it down. So from the very top, we've got a CPAP with the controller board. All of that was custom made, and I'll actually throw up a photo here of me making some jigs so that I could put everything where it needed to be. And so I drilled out some holes for the CPAP along with the actual motherboard plate, and then I just deburred them, made sure they were clean and good, and then added the actual 3D printed adapters here for the CPAP. Underneath this guy is a TPU ring, and that TPU ring will help with dampening a little bit of vibration, also with helping make sure that that area is a little bit more sealed up compared to everything else. So from the very top there, we've got we have got all of those motor drivers connected to the Manta M8 V2, and it's going to be running Clipper on a CM4 with a not a water cooling mount, a air-cooled fan right there, and this fan is going to get directly mounted to the board. We put the SSR right here, and one thing to know is something I didn't mention. All of this was custom made, so I had to spend some time in CAD and of course lay it out and make sure that it's all here. So it is very tight, as you guys can tell. Everything just about barely fits, but it does fit and it's cool. So literally it's cool. And so yeah, this is that process. I've got the SSR mounted right here, and it just, like I said, barely clears. It doesn't touch anything, and it doesn't touch these two items connected to the USB. So for the screen, which I've got right here, I've got the very popular WaveShare screen, and it's the long touch screen right here, which is perfect for the side pack. I did have to modify the case, and you can see where I modified it right there and there. I ended up taking some of my pliers these guys right here, and I ended up engraving a little scratch mark, intending for me to use my Dremel, but I actually just made a little scratch, bent it a couple times, and it all popped off, which is perfect because it made perfect space for my PCB cables right here. And as you can tell, this screen comes with, I think, normal USB cables, but I wanted to use some PCB cables, and it's a very nice, very tight fit. I got some PCB, some of these long ribbon cables from Amazon as well. I think they're about a foot long. I'll make sure to put these all in the description so you guys can use them. But it's a bit of a weird touchscreen where I have to actually connect a micro USB to the actual board for it to notice that it's a touchscreen. Usually it's like one of these two cables sends that signal, but I guess not. One is for signal, one is for power, and then I guess that small one is for USB and touch. So that's odd, but I ended up finding a USB ribbon cable adapter. And I don't think I mentioned this earlier, we are using the beacon, so you do have to use a USB hub. I found this one from StarTech, and this is a really good brand and really good company. So that I think what happens is that this board isn't properly grounded in one of the USB hubs, and the beacon can actually have its warranty voided because of that. So I use an inline hub, which is really nice because I can connect the beacon to that, and then I can connect my display to this, and maybe like a camera or something to the hub as well, because the beacon won't be always on. Moving on to the big chunkers right here, we got some USP power supplies. So the first one, if you can see right there, well, it's a little sideways, but it is a UHP 24 volt 350 watt connector. And then the big chunker for just the motors is a UHP 48 volt 500 watt power supply. So we've got that, and it was a pretty tight fit with the way that everything was going to be. So this is your power inlet from the wall, and I had to find a creative solution, and I found these little flag angle adapters. And of course this needs its own tool, but I didn't really care because it allowed me to be able to put these in. So I found a new tool, found a new thing, and then I plugged it all in, and then I moved the actual switch a little bit further up because I didn't want to reach around my printer to get it all plugged in. I've got some Noctua black 80mm fans cooling everything down, and that's about it. The other little nice little thing that I made was this Wahoo mount right here, and it connects all the three major Wahoo things that we need, which is earth, power, and ground. Everything, again, very tight, very concise, but everything clears and should be good for use. I have turned this on, everything does work. I even loaded up Clipper. So then the only thing I really need to do is pretty much plug in the motors and get a few things done. And so one thing I forgot to mention here is I actually found an antenna which can actually fit to the other side right here. I've got this pretty long, hilariously long antenna. But the other thing on this mount that I made is that there is a custom port right here for all of the tubes and the cables needed to come from the radiator, which I just got done showing you guys. So that radiator and all of its connections will come up through here. And I've got an antenna here because I always had problems with this having really weird Wi-Fi, but I realized getting a longer, nicer antenna really worked. But yeah, moving on to what is next with this printer. Obviously, I need to put on the actual side pack, and I will show you guys all of that in the next update. But putting on the panels, the side pack, the top, of course, doing its first couple prints, making sure all of the print CFG stuff is correctly working, and putting on the end stops, routing all of the radiator tubes, and just kind of making sure that everything is good. Once that's done, I really want to put it through its paces and see like what can we really do with this thing. And I want to show you guys that in the next video. Thank you guys so much for watching and supporting. I understand this video came out way after my first video, but you know, this project is a lot of R&D and takes a lot of just CAD time and personal time as I'm doing this in between other projects. So I hope you guys are enjoying all of this. I hope you guys get to really geek out with me with all of my custom things. I don't think I mentioned it, but yeah, the actual beacon is right there. But yeah, I hope you guys get to geek out with me on all of this stuff. If you guys have any questions or any things you want to see, want me to do with this printer, let me know, and I will definitely do that. And I hope you guys are having a great time. All right, take care.